Alright, so that one had ended by accident. So, right, let me get a white background. Alright, so this is actually look more like a blue color, right? Then going to the green. Alright, and of course with alcohol B, we said it was the tertiary one, so we did not expect it to give any color change. Alright, nothing is happening. So these two were were alcohol B. Alright, so it pretty much stayed the same. This is alcohol, not this one. This is alcohol A, alright, with dichromate and potassium permanganate. And this is alcohol C. So both alcohol A and C were oxidized. So those two would be the primary and secondary alcohols. Now, as you can see, alcohol A is 2-propanol and alcohol C is 1-propanol. Alright? This one is tertiary butyl alcohol. Tertiary alcohol. So you can see that both the primary and the secondary alcohols are oxidized, but the tertiary one is not. Alright, so continuing. So at the end, for the primary alcohol, we should have a carboxylic acid, and for the secondary alcohol, we should have a ketone. But remember, we added acid, the sulfuric acid, as the catalyst, right? So its presence would have still been in the test tube. So I have blue litmus paper. This is test tube A, which was 2-propanol, the ketone. You can see here, there's a small portion of it. Just a second. Right, so change to red. That means that would be due to the presence of the sulfuric acid, and the same thing for test tube C. So let us put a piece of magnesium in there and see which one gives faster reaction. Now this has a little more than this one, so let's just tip out a little. Right, it's almost the same, and the pieces of magnesium are basically the same size. Let's compare them. Obviously, you see that this one is reacting much faster than this one. Both of them are reacting with the magnesium metal. This one is doing it much faster and longer. Trying to come up with a reason. Not sure is it. So if you were asked to differentiate between primary and secondary alcohol, after the reaction you wouldn't have had any sulfuric acid as the catalyst. So on this I have C, which means C is the, if I did label it correctly and did not mix up anything, this is 1-propanol, which is the primary alcohol, right, which is still going on. This one is 2-propanol, which is test tube A. Alright, it reacted much faster. I'm assuming it has more of the acid, the sulfuric acid, which is strong. Alright, this is just me assuming. Now if this is test tube A, we expect it to, C, it's supposed to have the carboxylic acid, which is a weak acid. So all of it now, that is why it is reacting slowly. Alright, this would be the ethanoic acid, which is a weak acid. The reaction with the magnesium from this one, I'm assuming it would be with the sulfuric acid present. So once that is used up, the reaction would cease. But this container would have been ethanoic acid. Hence you're seeing it reacting with the magnesium metal slowly because it's a weak acid. And again, well, it don't stop because it, let me add more magnesium metal. Yeah. Whoa. Oh, yeah, sorry about that. So this is what is going on. This one has sustained its slow reaction. Right. So this, I'm assuming, right, this one is the weak acid. So I'm assuming any reaction with the one that is supposed to be the ketone would have been any remaining sulfuric acid that we had added to the container. Because remember, the sulfuric acid is the catalyst. So it would have been there. So in this one, at the end of it, you would have had a mixture of you would still have the sulfuric acid remaining, which is a catalyst, but also the ethanoic acid. So I guess now you can see what would happen if you, so if you react your magnesium, sorry, if you oxidize a secondary alcohol and the primary one, the litmus paper, oh, they have changed. Well, we mix them up now, but I think these were them. These were the two of them. Let me not, well, I'm not sure which two were they. They're mixed up now. Right, but if you oxidize a primary and secondary alcohol, then you add magnesium metal, not so convincing, alright? Both of them react the same. But based on our experiment here, we see that the primary alcohol, which would have been oxidized to the carboxylic acid, it reacts slowly with the metal, which is what is expected. But the one that is supposed to be the ketone, it is still reacting as well. So, or probably it hasn't fully gone to the ketone. Let me see something. Give me a second. Where's the magnesium? Alright, as I can see here, I dropped it in the alcohol A. No reaction is taking place. Just a second. So this is an experiment. We can do it. Alright, so let me pour some of the alcohol in this test tube. Alright, and then add the acid. Alright, and let's place a piece of magnesium in it. Notice which container reacted the same, like this one. Where were they? This one is test tube C, which was the 1-propanol, but this one is test tube A, the 2-propanol. And if you notice, the 2-propanol one, right, which would now be propanone, the ketone, this is just the alcohol and the acid, right? So that is what I was saying. This reaction that is going on in this one would have been with any sulfuric acid remaining. And as you can see, both of them are reacting similarly. Right? Hope you're seeing that. So I'm going to try, let's add potassium permanganate, a lot of it, and see what happens. And see if it slows down the reaction. I'm going to add a lot of it. This is us trying to differentiate, just following up with the primary. We already oxidized it, right? So we know it should be a ketone and the other one should be a carboxylic acid. Also, I had done as well, I had put the two of them at the Benedict's solution. So you know, if it was an aldehyde, it would have given a color change. And okay, where's the test tube holder? This is test tube C. As you can see, it is still blue. And test tube C was the primary alcohol, which means it is not an aldehyde, it's a carboxylic acid, because the copper 2 ions, which are present in both Phelan's solution and Benedict's solution, would have been reduced to copper 1, which is why you would get the red color. So we can see that C is not an aldehyde, it has gone to the carboxylic acid. Okay. The other paste more and see what will see if any more fizzing occurs. Yes. Alright, so if you were doing this, because this is not in any textbook, as in following up what would have happened, so now you can see what would have happened. So we see that the litmus paper, it doesn't really help us a lot because both of them gave us similar change. So if you wanted to distinguish between primary and secondary alcohol, oxidizing it, in theory, oxidizing it, and then carrying out a secondary test for the acid or the ketone can work, but in practice, it would probably take some adjustments, right? So if you want to differentiate between, the background was a bit noisy a while ago. So if you want to differentiate between primary and secondary alcohol, it's best to do a direct test, so like the iodoform test, right? So oxidizing, but for exam, you oxidize it and then you carry out a secondary test, meaning carry out a reaction for carboxylic acid or the ketone, will like the Brady's reagent, right? 2,4-dinitrophenyl hydrazine. So you could do that. But as we see in practice, it probably needs some adjustments to get a better differentiation between the two reaction. As you can see, test tube A, it's still going. Test tube C. So which test tube did I use? Oh. Alright, so that's it for this video. I hope it was useful. Remember to leave a like, share, comment, whatever. Alright, subscribe. Yeah, so in the other video I'm going to do the talents, no, not the talents. Yeah, the silver mirror test and with the Phelan solution. So that's it for this video.